Hello everyone, welcome to RoboGuru online programming course. Today we will look at conditional statements. We'll see how a program takes a decision. So here are some disclaimers, you can read them. So what we will learn today is what are conditional statements. We'll see some daily life examples of conditional statements. We also see that how electronic devices takes a decision. We'll also see types of execution of a program, programming switches and LEDs, and more programs on conditional statements using LEDs and switches. Yes, today we will introduce three new things: conditional statements, LEDs and switches, and we'll write some programs on that. So in our day-to-day life also, it is based on a lot of ifs and buts, if or then. So for example, if it's night, then you will sleep. If it's Diwali, you will light a diya. If it's hot outside, then you will turn on a fan or a AC. So even our lot of daily life, day-to-day life events are based on certain actions, certain events. So these events can be like when you go out of the house, you will wear a slipper or shoes. When you come into your house, you will take off your shoes. You will put your bag. So these are things which are driven by certain events in our day-to-day life. So similarly, electronic devices, we have to allow them to take certain decisions. For example, if we talk about mobile phone, when you dial a number and click on call, a mobile phone is programmed to give a call on the respective number. Similarly, an automatic washing machine is programmed to wash your clothes for a specific time. After that, it stops itself. An air conditioner takes a decision of switching itself off after a specific temperature is achieved. A television is programmed to act according to the commands sent by the users to the TV. A refrigerator also takes a decision of switching itself off after a specific temperature is achieved. So electronic devices also takes a lot of decisions. So what are conditional statements? How we can program these electronic devices to take their own decisions? It's by conditional statements. So what are conditional statements? Conditional statements are used to decide the flow of execution based on different conditions. If a condition is true, you can perform one action. If a condition is false, you can perform another action. So here's a flow chart of conditional statement. So if the condition is true, if there is a condition and it's true, code inside if body will be executed. And if a condition is false, code inside else body is executed. So here is the syntax of if statement, if and else statement, if and else conditional statement. So we will write if. After that, there will be a condition. A condition can be anything. It can be an event. So this event can be like a switch is pressed, a sensor detects something, or maybe your counter reaches, there is a counter. Suppose you are counting from 1 to 100 and counter reaches 100. You want to do something after that, you can do. So if that condition is true, whatever the code you write, whatever the instruction you write in these curly brackets will be executed if that condition is true. We can write else also. Although it's not mandatory that with if you need to write else, you can write if also, only if. So if there are two conditions, if and else, if there are two conditions, if you want something to happen with one condition, you can write all the instructions there. If you want something to happen, if that condition is not happening, if that condition is false, then you can add some more instruction. So you will write all the instruction which should be executed. If a condition is true, then you need to write all those instructions between these curly brackets of if. If you want something to be executed, if the condition is false, all those instructions should be written inside this else body or inside this curly brackets of else. Let's see types of execution. There are two types of execution. First is time triggered. So when a certain task is completed, the program executes a task. So this is something we have already done in our previous classes. Like we have made a robot move in a square, circle, triangle, rectangle. So that is because of timed execution, time triggered execution. So we say that after maybe 920 milliseconds, robot will turn 90 degree. After that, the robot should move forward. So this is a time trigger. The time is triggering an action. This is being used in refrigerators. This is being used in washing machines. So after a certain time, the washing machine will stop. It will keep on washing the clothes, and after a certain time, let's say of 45 minutes, 40 minutes, it will stop, because it will consider that after 40 minutes or 45 minutes, the clothes are completely washed, completely cleaned. Similarly, there is a triggered execution called event triggered execution. So when a certain event happens, the program executes certain task. So event can be anything. Like if we talk about air conditioner, event is something like when the required temperature is achieved. So what you do is you set a temperature of 24, and when that temperature of 24 is achieved, the air conditioner will stop. There are some cases where event triggered systems are considered better than time triggered. You should search this and see why event triggered systems are considered better than time triggered. So if we take an example of elevator, it has both time triggered execution as well as event triggered execution. So if we talk about when you enter into an elevator, after a certain time, let's say of 10 seconds or maybe 15 seconds, door will start closing, right? So that is a time triggered execution, that it's been programmed in a way that if someone enters or exits, after a certain time of 10 seconds, maybe 15 seconds, door should start closing. But when a person puts a hand in between both the doors, or he gets inside while the doors are closing, the elevator is programmed to, because this is going to be an event. This is going to be an event for elevator, because there are sensors between the doors of the elevator which senses that, okay, someone has entered, I should open again. So this is an event. So elevator is a classic example of time triggered execution as well as event triggered execution. So there are some things called switches and LEDs. Switches will be considered as input. LEDs will be considered as output. So some things, any electronic device, any device which gives a input, which gives some kind of an input to the program, because switches can be considered as an input, sensors can be considered as an input. If they give some certain input to the program, it's they are considered inputs. Anything which can be controlled by LED, because anything which can be controlled by a program is the output. So LED, motors, maybe actuators, these things can be considered as outputs, because a program cannot cannot control a switch. It cannot control a sensor. It can only control certain outputs like LED, LCD, motors, actuators. So you can use these switches to program different things. For example, like switch 1 can be, so as you know, there are 4 switches available in IO panel. So switch 1 can be used to make robot go forward, glow a LED, write something on LCD. All these switches are programmable. You can use any switch to program anything. Any switches as input can be used as an input to drive some certain output like LED, motor, switches, moving robot, all of that. So let's write some programs. So first program is write a program to control an LED using a switch. So here we need to write a program so that we will be able to control a LED using a switch. So first thing is, whenever we are writing a program for a switch, it's mandatory that you use a repeat loop. Because if you are not using a repeat loop, it's going to execute, it's going to run a program only one time. So if you are not using repeat loop, the program is executed only one time. It's not going to check again and again that if switch is being pressed, if switch is being pressed, if switch is being pressed. It's not going to check again and again, only one time. So in order to check again and again, a repeat loop is mandatory. So here our task is we need to control a LED using a switch. So here we will use a conditional statement. We'll go to conditions, add if. So here immediately you can see after if, it's pointing us to add a condition. So what will be the condition? That switch is pressed. So we'll go to IO commands, go to switch, select switch 1, any switch you can choose. Let's select switch 3. So if switch 3 is on, what should happen? Our task is that if switch 3 is on, LED should glow. I'll just open my IO panel. So if switch 3 is on, our LED should glow. So I'll go to IO commands and add an instruction that LED 1 on. So if switch 3 is on, LED 1 will be on. Similarly, we can add a else statement also. We can go to else. Here again we need to provide a instruction. So we can provide that LED 1 off. So what is our program? That if switch 3 is on, LED 1 should be on, else it should be off. So whenever we talk about if else statement, one thing will eventually happen. If this is not happening, this will happen. If this is not happening, this will happen. Okay. If statement is not executed, else statement will be executed. One thing will eventually happen. So if I just run this program, you can see that whenever I press switch 1, LED will be on. Whenever I release it, LED 1 will be off. So this is LED 1, this is LED 2. So here we have programmed that if switch 3 is on, LED 1 will be on. So if I press switch 3, LED 1 will be off. When I release it, LED 1 will be off. So we can clearly see here that if switch 3 is on, LED 1 is turning on, and when I release switch 3, it's turning off. So what if I remove this else? Let's see what happens. So we can run a program by only if also. If you don't have two conditions, because in if and else statement, we require two conditions, because if one thing is not happening, other thing should happen. If you want to run only one condition, that is also possible. So switch 3 will control only LED 1 on. After that, there is no condition to turn it off. So if I press switch 3, it will be on and it will be continuously on. There is no command to turn it off. So if I press switch 3, it's on. If I press it again and again, nothing is going to happen, because LED 1 is already on and there is no command to turn it off. Let's try something else. Let's try some other program. The program is write a program to control motion of robot in one direction using a switch. So here we need to write a program so that we can control motion of robot using a switch. Let's say instead of this LED 1, I write forward. So if I press switch 3, robot will keep on moving forward. And since we haven't given any other program to stop it, it will keep on moving forward. So if switch 3 is on, robot will keep on moving forward. It won't stop. In order to stop it, we need to add one more condition, or else. Here we will write stop. So if switch 3 is on, robot will move forward, else it will stop. If switch 3 is not on all the time, if switch 3 is not on, the robot will be stopped. So if I run this, so you can see that robot is you can see that if I press switch 3, robot will be moving forward. If I release it, robot will be at stop. So switch 3 is on, robot is moving forward. If I release it, it will be stop. Yeah, correct. Let's look at another program. Write a program to control LED 1 and 2 blinking using switches. So here we need to use two switches, switch 1 and switch 2. Let's take two switches. Let's take switch 3, no problem. So we need to control LED blinking. I'll first show you how LED blinks. I'll go to IO panel, add LED 1 on, then add a delay, a small delay of maybe of value 200 milliseconds. Then I'll add a command of LED 2 on, LED 1 off, then add a small delay of 200 milliseconds. So LED 1 is on for very less time, then LED 1 is off for very less time. Okay. So if I press switch 3, LED 1 will start blinking. So LED 1 will be on for very less time and LED 1 will be off for very less time. So this on and off keep on happening again. That's why this LED will keep on blinking. So you can see that LED is blinking until I've pressed switch 3. So if I release it, whatever the last command it was executing, it's going to execute that. So it could be this one, it could be this one. So I press switch 3. So you can see that it has started blinking. So the last command it has executed is LED 1 off. That's why it's always off. If you want to add one more command that we can, as I've already told you, we can include if more than one if conditions. So we'll go to switch. Let's select switch 1. If switch 1 is on, let's blink LED 2. So LED 2 on, then add a delay of 200 milliseconds. Then LED 2 off. Then again delay of 200 milliseconds. So this is our program. If switch 3 is on, LED 1 will start blink. If switch 2 is on, LED 2 will start blink. Let's change this one to 1 and this one to 2. It's better. So switch 1 will control LED 1, switch 2 will control LED 2. So switch 1 on, LED 1 is blinking, switch 2 on, LED 2 is blinking, right? So that was our program. So write a program to blink LED, display motion and move robot using a switch. So three things we need to do. We need to blink LED, which is already there. We need to move robot, let's say I have written forward, and we need to display the motion also. What is the motion? It's moving forward. So we will write LCD clear, then we will write LCD message, and in message we can write forward. Okay, so I'll just remove this and add an else, because let's add one more condition. What if when switch is not pressed? Let's write a condition for that. If switch 1 is not pressed, let's say the robot is stopped, LED 1 is off, LED 1 is off, and LCD is cleared. Okay, so three instructions we have written. So if I run this program, you can see that if switch 1 is pressed, LED 1 will blink, LCD will blink forward, and robot will start moving forward. Then if switch 1 is not pressed, robot will be stopped, LED 1 will be off, and LCD will be cleared. So let's press switch 1. Robot is moving forward, LED is blinking, and forward is being displayed on the LCD. If I release switch 1, everything will be removed. LED is off because of this. Robot is not moving forward because of this, and LCD is cleared because of this command. Okay. Write a program to move robot in all four directions with an individual switch for each motion. Let's try this. So we need to move robot in different directions using different switches, and these should be individual switches. So like switch 1 should control forward motion, switch 2 should control backward, switch 3 left, switch 4 right. So let's try this. We'll go to condition, add a if. In conditions we will write switch 1. So if switch 1 is pressed, let's say robot moves forward. If switch 2 is on, let's say robot moves backward. Again, if switch 3 is on, let's say robot moves left. Then again, if we go to if we go to if and add a condition, the condition will be switch 4 on. Now robot should move right. Okay, so these are the 4 conditions for all the 4 switches. So if I run this program, moving forward, backward, left and right are there, but there is no stop command. So if I start running, if I release any of the switches, the last command which was there will keep on executing. So if I run this program, so here you can see that if I press switch 1, robot will keep on moving forward, and if I release it, it will not stop, it will keep on moving forward. Similarly for switch 2, switch 3, switch 4. I can use switch 1 to make it move forward. I can use switch 3 to turn, then forward. I can use switch 4 to turn right, then forward. Let's say I want to move a little bit backward, turn right or turn left, then moving forward. So it will keep on executing the last command, whichever is there. So in order to add a stop, if I add a stop, let's say here in the else command, else robot is stop. So you will see something interesting here. So you will see that whenever I am executing forward command, which means whenever I am pressing switch 1, robot will be moving faster. For the rest of the 3 commands, if I press switch 2, switch 3, switch 4, robot will move a bit slower. This is interesting. Let's see. So if I press switch 1, robot is moving faster. You can see here also that robot is moving a little bit faster. But again, if I press switch 2, it will be little slower. You can clearly see that robot is moving a little bit slower than switch 1. Similarly, this is for switch 3 and switch 4 also. Robot will be moving slower. Here also and here also. You can try this code also and check it yourself if you're not able to see it clearly. So here what is happening is this else is a part of this if. This stop is a part of forward, only forward. This else is a part of only this forward. So if switch 1 is not pressed, this command will be executed every time. If we press switch 2, switch 3, switch 4, switch 5, switch 4. So what happens is when I press switch 2, this stop command and backward command will be executed. So this one, so it will execute stop, then backward, stop, backward, stop, backward. So it's continuously stopping also and moving backward also, because of which speed reduces. Similarly for 3, if we press switch 3, it's stop left, stop left, stop left, because of which the speed reduces. Similarly for right also. But for forward, it's moving only forward, because if I press switch 1, only this command will be executed. Stop will not be executed, because if we talk about if else statement, if it's conditional statements, if they are written closely, if they are written one after that, one after each other, then only one command will be executed, either this one or this one. Okay, so in order to solve this issue, there is something else which is called else if. So instead of this if, we have to write else if, ELSE. You can also choose it from there. I am writing it here. You can also choose it from the conditional statements also. So now I have added 4 commands. So you need to understand one thing, that else if commands is used every time whenever we have more than 2 conditions of same type. Okay, so these conditions are same, that if switch 1 is pressed, switch 2 is pressed, switch 4 is pressed. Whenever we have more conditions of same type, more than 2 conditions of same type, we have to use else if. Because if we are using else if, this from this to this point, everything becomes a one program, one conditional statements. It's going to execute only one of these conditions. So if switch 1 is pressed, it will move forward. If switch 2 is pressed, it will move backward. Switch 3 left, switch 4 right. If nothing is pressed, it's going to execute stop. So it's going to check again and again each and every condition. So whichever condition is true, it's going to execute that. So if I press, let's run this program first. So whenever I release a switch in this program, the program will execute the else command, because no switch is pressed. So it will execute the last command, which is else command, which will be stop. So if no switch is pressed, it will be stop. Switch 1, if I press switch 1, it will move forward, and if I release it, it will be stop, because now no switch is pressed, it will execute the last command. Similarly, switch 2, and if I release it, it will be stop. If I move left or right, it will be, if I release it, it will be stop. Robot will be stop. Let's look at the another program. Okay, we'll look at that later. So what are the conditional statements? That is something we have learned today. Some daily life examples of conditional statements we have seen. We have seen how electronic devices takes a decision. Also, we have seen types of execution of programs, that is time triggered execution and event triggered execution. We have seen some differences also between them. And we have seen how to program switches, LEDs using a conditional statements also. So for your homework, you can try this program. Write a program to move robot in all 4 directions with an individual switch. This is something we have already done. For each motion, also display motion on LCD. That means if your robot is moving forward, LCD should display the motion also. That if you are moving, if you have pressed switch 1 and it is programmed to move robot forward, then LCD should display forward also. This is something we have already done, but now you have to do for all the 4 switches. And every time LED 1 is pressed, every time any switch is pressed, LED 1 should glow. So this is again a small program which you need to write. So there will be more number of if statements in your program. Second thing, you need to find out more devices which are programmed to take decisions. Third thing, you need to categorize these devices in the group of time triggered devices, event triggered devices, and combined triggered devices. Time triggered devices, I have already told you that a washing machine can be considered a time triggered device. Event triggered device can be an air conditioner, and combined triggered device can be considered as a elevator. Thank you.